Welcome to our deep dive into programming tricks for embedded systems. In this video, we'll explore practical techniques that save time, memory, and debugging effort. Embedded systems programming is all about writing predictable, efficient, and maintainable firmware under real-world constraints. Unlike desktop or web development, embedded engineers face limited RAM, strict timing budgets, hardware quirks, and long product lifecycle. These challenges force us to think differently and adopt proven strategies. Let's start by understanding why these tricks matter and how they can elevate your embedded projects. Before we jump in, here's a quick look at the topics we'll cover. From determinism to bitwise operations, named constants, lookup tables, ISR-safe functions, compile time checks, debug hooks, explicit state machines, main loop scheduling, and writing maintainable code, each section is packed with actionable advice. Whether you're working on bare metal systems, RTOS-based designs, or resource-constrained microcontrollers, these tricks are universally valuable. Let's get started with our first principle: prefer determinism over cleverness. Embedded systems, determinism is often more valuable than abstraction. Deterministic code behaves the same way every time, making it easier to analyze, test, and certify. This is especially critical for real-time systems where unpredictable behavior can lead to failures. By avoiding dynamic behavior and preferring static alternatives, you ensure your firmware is reliable and maintainable. For example, use fixed-size buffers instead of dynamic allocation and explicit state machines instead of deeply nested conditionals. Let's see how this principle shapes robust embedded code. Memory is precious on microcontrollers. Bitwise operations allow you to encode multiple states or flags in a single variable, saving RAM and speeding up checks. Pack Boolean flags into bitfields or bitmasks instead of separate variables. This technique is perfect for peripheral status flags, error conditions, and feature-enable-disable switches. However, avoid overpacking unrelated logic. Group bits by responsibility to keep your code readable. Bitwise tricks are a staple for efficient embedded programming. Magic numbers make embedded code fragile and hard to maintain. Always replace raw values with named constants or enums. This makes calibration easier, refactoring safer, and debugging clearer. For instance, instead of using a raw value like 723, define a constant such as add cov-RVOLT threshold. This practice is especially important when values come from datasheets, timing requirements, or electrical limits. Named constants clarify intent and prevent costly mistakes. Math operations are expensive on small MCUs, especially without a floating point unit. Pre-compute values at compile time and store them in lookup tables. This approach is common for sensor linearization, gamma correction, PWM duty cycles, and voltage register mappings. Lookup tables offer faster execution, predictable timing, and reduce code complexity. While they consume flash memory, flash is often cheaper than CPU cycle. Use lookup tables to optimize performance and simplify your firmware. Interrupt service routines, ISRs, impose strict constraints. Design low-level functions so they can safely be called from both ISR and task context. Avoid blocking calls, do not allocate memory, keep execution time bounded, and use volatile and atomic access correctly. Advanced tip: split logic into two layers, an ISR layer that captures data and sets flags, and a processing layer that runs in the main loop. This pattern simplifies interrupt-driven designs and improves reliability. Embedded bugs discovered at runtime are costly. Use static assertions and compiler warnings as design tools. Validate structure sizes, verify array bounds, and ensure configuration consistency. Compile time checks catch errors before flashing hardware, making refactoring safer and supporting easier multi-platform development. A warning-free build should be a non-negotiable rule. By leveraging compile time tools, you prevent issues early and build more robust firmware. Debugging hooks aren't just for development builds. Design lightweight diagnostic hooks that can remain in production firmware. Examples include conditional debug GPIO toggles, circular debug logs in RAM, and error counters exposed via communication interfaces. These hooks provide visibility when failures occur in the field, without invasive changes or reflashing. Building debug hooks into production code ensures you can diagnose issues quickly and efficiently. As systems grow, flag-based logic becomes unmanageable. Model behavior using explicit finite state machines, FSMs. This approach offers clear behavior flow, easier testing, and fewer unintended transitions. Explicit state machines are particularly effective for communication protocols, power management, and peripheral sequencing. A well-designed state machine often replaces dozens of conditionals, making your code more maintainable and reliable. Even without an RTOS, you can structure firmware like a cooperative scheduler. Break logic into small non-blocking tasks executed from the main loop. Key rules: no delays, no blocking waits, and each task runs fast and returns. This approach improves responsiveness, simplifies timing analysis, and makes RTOS migration easier later. Treating the main loop as a scheduler is a powerful technique for embedded systems. Most underrated embedded programming trick is clarity. Write code assuming it will be read months later under pressure. Use clear nomming, consistent formatting, concise comments explaining why not what, and minimal cleverness. Maintainability is a form of reliability in embedded systems. By prioritizing clarity, you make your code easier to debug, extend, and hand off to others, whether that's a teammate or your future self. Programming embedded systems is an exercise in discipline. The most effective engineers rely on simple, repeatable tricks that reduce uncertainty, not clever hacks that impress in the moment. By favoring determinism, leveraging compile time tools, structuring logic clearly, and designing for observability, you build firmware that survives scaling, debugging, and real-world abuse. These habits separate prototypes from production systems. As your embedded projects scale, the importance of these programming tricks becomes even more apparent. Structured logic, compile time checks, and observability features make debugging easier and ensure your firmware can handle real-world abuse. These techniques are not shortcuts, they are the foundation of robust, production-ready systems. By adopting these habits, you set yourself apart as a disciplined and effective embedded engineer. Let's recap the practical examples discussed. Fixed size buffers, bitwise operations, named constants, lookup tables, ISR-safe functions, compile time checks, debug hooks, explicit state machines, main loop scheduling, and maintainable code. Each trick addresses a specific challenge in embedded development, helping you write firmware that's efficient, reliable, and easy to maintain. These examples are drawn from real-world experience and are proven to work across a variety of embedded platforms. These programming tricks are applicable across bare metal systems, RTOS-based designs, and resource-constrained MCUs. Whether you're working with a simple microcontroller or a complex embedded platform, the principles remain the same. By focusing on predictability, efficiency, and maintainability, you ensure your firmware is ready for production and can handle the demands of real-world applications. Observability is crucial for embedded systems. By building debug hooks and diagnostic features into your firmware, you gain valuable insight into system behavior. This allows you to diagnose issues quickly, even in production environments. Observability features such as debug logs and error counters make troubleshooting easier and help you maintain high reliability in your embedded products. Maintainability is a form of reliability in embedded systems. By writing clear, well-structured code with consistent formatting and meaningful comments, you make your firmware easier to debug, extend, and hand off. This reduces the risk of errors and ensures your code remains robust over time. Maintainable code is a hallmark of professional embedded engineering. Habits discussed here separate prototypes from production systems. Prototypes may rely on clever hacks, but production firmware demands discipline and repeatable tricks. By adopting these programming techniques, you build systems that are scalable, maintainable, and ready for real-world deployment. This mindset is what distinguishes successful embedded engineers. Summarize, the key programming tricks for embedded systems include favoring determinism, using bitwise operations, replacing magic numbers with named constants, leveraging lookup tables, designing ISR-safe functions, aggressive compile time checks, debug hooks in production, explicit state machines, main loop scheduling, and writing maintainable code. Each trick contributes to building reliable, efficient, and scalable embedded firmware. Thank you for joining this journey through embedded programming tricks. Remember, these techniques are not shortcuts, they are the foundation of robust, production-ready firmware. Keep exploring, keep learning, and apply these principles to your next embedded project. With discipline and the right habits, you'll build systems that stand the test of time and scale with confidence.